Dear participants, I'm pleased to welcome you to our webinar on flow sensors from Höntzsch today. My name is Manuel Frinke. I'm your moderator today, giving the instructions and handling the question and answer part in the end. Uwe Schmidt, sales manager at company Höntzsch, will hold the webinar as subject matter expert. I am marketing manager at EMT Group and will be here to take care of your questions during the webinar. In the webinar itself, we will look at the measuring principles of the Höntzsch portfolio and how it covers most demanding applications in different environments. We will give insights and examples how our equipment is dealing with harsh operating conditions and how it is designed to deliver most accurate measurement results. Now, before we really get started, just a few words about the webinar agenda. This webinar today will be recorded while maintaining your anonymity. We will make it available as a stream to all participants. If you want to have it, please let us know through the chat. If you would like to receive an abstract of the presentation from us, please also post it in the anonymous chat. You will receive an email from us after the webinar with the attachments. You are invited to ask questions in written form through the chat, please. For organizational reasons, we will collect all questions and I will ask them to Mr. Schmidt on your behalf at the end of the webinar. If you would like us to contact you after the webinar, please also post this in the chat. So only us can see your entries, so it's anonymous. And then we will get back to you shortly after the show. Okay, so thank you very much, and let's get started. With this, I hand it over to Mr. Schmidt.
Thank you very much, Mr. Frinke, for the nice introduction, and welcome everybody in the line from my side. My name is Uwe Schmidt, and I'm the sales responsible here at Höntzsch. We are 50 people at Höntzsch. We develop, design, and manufacture flow sensors, and obviously we sell them. We sell them in all around the world, basically. This is by using a lot of agencies. Some of you take part today in this webinar. When I started at Höntzsch some more than 3 years ago, I was introduced into the wide range of flow sensors, and this graph shows the large variety of different flow sensors. Now we have we focus here on 4 different physical working principles. This is first of all the vane wheel sensors that can be used in gases and in liquids. We have then the vortex sensors. I will come to that a lot of times in the following presentation. This is our problem solver for very demanding applications. We have the mass meter, flow meter, the thermal flow meter, and we have quite lately developed the ultrasonic flow meter for example, combustion air in combustion air stands. Now, why is Höntzsch on the market? Why can we survive with all these different flow sensors and so many different competitors on the market? This is because we have focused in the last more than 50 years on extreme applications with extreme demands. For example, if you want to measure hot air or hot gases up to 550 degrees, then we have very few competitors. If we want, or you, the end customer, want to measure gases that are basically that hold a lot of dust up to 90 grams per square meter, then we can measure those gases, and not so many competitors are around there any longer. The same applies for varying gas compositions, or if you have a mobile measurement in explosive areas. So we have thereby been successful by looking at very specific applications. So when I started here, I tried to understand this, and I have started to collect the typical applications and the successful applications. First of all, this was done in PowerPoint with some slides. And now over the last 9 months or so, we have started to upload those applications on the internet. I will now introduce you into some of those applications. What you see here is an operator welding, and you see that he is very heavily protected, obviously for his eyes, for the sparks coming from the process, but also from the dust that is created by the welding process. And nowadays, in modern workspaces, the exhausts, the dust coming from the welding process are directly collected by these vacuum suction systems. They are collected from maybe several workspaces, and the airstream is then measured in order to control these exhaust principle, or this exhaust process. Now you can imagine, if you have such a lot of dust in the air and particles, then the sensor, as you see on the right-hand side, is under heavy demand, sees a lot of demand from these particles. Nevertheless, it is still measuring. So this is why we use, for these harsh conditions, the vortex sensor. Höntzsch and tobacco industry. That's a long relation. We have served a lot of different companies that produce these tobacco processing machines for drying and for producing the cigarettes. I will now introduce you shortly in one of the first processes after growing the tobacco. The curing is the first process, basically, when the plants come directly from the field. When they come from the field, they are green, as you can see here in the 6 different pictures. So they come green to the curing chambers, and then they start the process of curing these leaves. Now, what indicates this process, or what is the indication of the process? Basically, the indication is the color. So the process takes part, or will be carried out until the leaves reach or receive the right color. That's a light orange. You can see the color here on the right-hand side with particles on our sensor. So the process is controlled using video cameras to check the color, and the process is also controlled by controlling the flow that goes around, carrying the hot air and guiding it along the different leaves, all the leaves that are stored here. And our part here is to control that airflow with using our sensors. There are many more of those processes along the tobacco production until you receive the complete cigarette, and we also work in these different machineries. Totally different industry, but a similar process. The wood industry. At the moment, we see here, at least in Germany, a high demand on wood, and there's not enough wood around for the carpenter, for example, to work with the material. Now, what I want to show you here is the process of how they basically take out the moisture of the freshly felled wood. If you fell the wood, then it holds a lot of moisture. That's clear. Now they bring these wood materials, the wood, into these chambers. You see the comparison to the tobacco industry, and as well here hot air is used to dry the wood. Now here it depends on what you want to use the wood for. According to the application of the wood, you are willing to leave a certain amount of moisture in the wood. And the flow here is also controlled by our sensors. So again, it's to control a process of curing, drying, or here taking out the moisture of the material. Now that could be done with different sensors. The point is that if you have a lot of air that is covered or that is laden with the moisture, then some sensors would not work. And this is why our sensors are quite good to use in those applications. And you see also the particles that come from the wood with the dust and with the air that can quite be demanding for the sensor. On the left-hand side, you see the sensor after a certain amount of time when it was in the process, and then you can easily clean. It doesn't look new, but it is ready for be used again in the operation or in the process. We are approaching the next general election here in Germany, and everybody is talking about environmental principles or environmental issues at the moment, now that the corona crisis is about to be overcome by the nation here, that the next big theme will be environmental discussion. And due to the election, it's on the top of the agenda. And we are part of that process or of that topic, because we have sensors that can be used to measure the airflow, the exhaust of large power plants, for example. And again, the picture look all the same or very similar. The sensor is in the flow and it is quite polluted by the polluted air, by the polluted gas. Nevertheless, it is able to still measure, and you can easily retract it from the process, clean it, and then put it back into process. As you can see from the gentleman here, this is an application that was sold to China, and we have been here to take care of the installation. What we also do is to support the customer when they first put the sensors in operation, or obviously after sales service. Very interesting on that picture on the left here is you see the screws that are quite rotten already, but the sensor is still operating. It's made out of stainless steel or even other materials. Lately we have developed and brought a plastic sensor on the market for very demanding aggressive gases. So the sensor material is is robust enough to be used in these harsh environments. Think a minute of what that could be. It is liquid nitrogen, so very, very cold material. And we have a solution to measure the flow of liquid nitrogen at -198 degrees. So why would anybody want to measure this liquid nitrogen? Because the liquid nitrogen is used, for example, for milling processes. If you want to work or mill rubber, for example, it's just too soft to be milled. You can only cut it. But sometimes you want to form it in a special way, and therefore you have to cool it down. And that can be done using liquid nitrogen. And then the material becomes very hard, and then it is easily to be processed. So the flow of this liquid nitrogen, that's a task that we have solved using the vane wheel sensors. Spray process, spray painting of, let's say, furniture, of cars, of all different goods, is nowadays state of the art. It is used to precisely put just enough paint on a product, to put more or less paint on certain areas, to form the spray, to direct the spray according to where you want to spray. And all this can be done using pneumatic spray nozzles. Nevertheless, as you can see on the picture, spraying paint on a surface always creates so-called overspray. Some of the paint particles move to the surrounding environment. And because this spray can't be just let out in the open air, it is collected. This process is a standard, and it's collected and then it's concentrated, as you can see here on that chart. It is concentrated until you have a highly laden airflow into a thermal oxidation process. And the clean air is directly let into the open air because it's clean, it's cleaned, and the concentrated one, that has to be taken care of. So what is a thermal oxidation process? This is one of our top selling processes. Well, we don't sell the process, but we sell the sensors that can be used in such a process. Let me briefly introduce you into the process. Basically, as we have seen, we have the exhaust gas, for example, from a paint booth. That is going here, the heat exchanger. So it's warmed up and it's brought into the combustion chamber. And what is happening in the combustion chamber? There you have a flame that is fed by the natural gas and air. So we have a flame here heating the chamber up to, let's say, 800 or 1000 degrees Celsius. And therefore, the exhaust gas coming in is basically oxidated. And as a result, we get only CO2 gases and some water. That's the results of this process here in the combustion chamber. And therefore, we can leave the cleaned air out in the open. On the way back, it heats up the incoming air in the heat exchanger. Now, where does Höntzsch come in? For example, we can control the airflow or the gas flow into the flame, or for the flame of the natural gas. We can control the airflow that is required to produce the correct heat here. So by using just enough air or the oxygen in the air, we can control the flame inside the combustion chamber. And sometimes customers require that to be a CO2 application or sensor. And very interesting as well is the exhaust gas, because it is dirty, it is laden of the particles that can be controlled using a vortex sensor. And then the, so to say, clean air coming out also is monitored. That's for environmental reasons, because the industry or the companies have to inform the national bodies of how much exhaust air they bring into the open air. So what was that picture? What is that to do with the ships? On the modern ships, the cruise ships, here the Aida Nova from the Meyerwerft in Germany produced, a very, very large ship, is now also for environmental reasons now equipped with an LNG engine. So it is running on liquefied gas. Because of that gas, or the gas used here in the engine, there's always the possibility of leakage in the tank or from the pipes coming from the tank to the engine, and also in the engine and in the exhausts. Therefore, the rooms where the engine and the tank is placed have to be controlled. First of all, they have to be ventilated. So the requirement is to ventilate those rooms 30 times an hour. So there has to be a large amount of airflow taking place. And if that would not be the case, it could create an environmental situation, and we won't like to have that. That is symbolized here. Okay, this is an insight into the ship, an inside look into the ship. You have the storage, the tank of the liquefied or liquid natural gas, and then you see 3 pictures of our sensors on board. Those sensors are now on board for more than 2 years. Unfortunately, last year they haven't been in operation. The ships have been in the harbors, but now they already offer again. They offer again these cruise turns, and our sensors will be back on the ocean and will be used there to control the airflow into and out from the engine rooms and the tank rooms in the ship. So that was in 2019 a brand new market for us and a very successful market. And we are looking forward for people going on board on the cruise ships and being the airflow downstairs, so to say, in the engine rooms will be controlled using our sensors. The same forced ventilation applies for battery rooms or in environmentals where batteries are produced. Also a very modern market because of upcoming more electricity on cars, on trucks and so on. Then therefore we obviously need more batteries, and batteries are produced all around the world, and this is why these production facilities have to be ventilated, that's for sure. And we can be part of that game when we sell our sensors into these industries, into these applications. In such applications, we see a lot of times that they have to be ATEX, according to ATEX, sometimes even zone 0, sometimes zone 1. And linked to that, a lot of times it is required to have seal certificated sensors in use. And that is what can be done using the vortex sensor with the certain design, especially designed for the ATEX environments. So this was the information from my side. You will find more of these demanding applications, our top selling applications, on our internet web pages. The link is here, and Mr. Frinke has already included that in the chat. And that's all from my side and my colleagues, the experts in application. I thank you very much for participating today, and I hand over to Mr. Frinke for the discussion.
Thank you, Mr. Schmidt. Yeah, so that was interesting, and we got some questions here from the audience, and I would like to start with the following. Is the vortex flow meter MID2 compliant?
MID2.
MID2, yeah.
I'm not aware of MID2, sorry, but I will take a note, and maybe we can get an explanation of what MID2 stands for.
Yeah, maybe we can get this to the chat. In the meantime, I would like to ask you another question regarding wood applications here. So
okay.
do you notice poisoning gases from, for example, oak wood?
We have not been confronted with poisoning airs, but if there's a poison, the situation would be, or the point would be to clarify what is the poisoning contamination, what sort of gas is that, and what we do is to compare our material to the material or to the gas in use, in operation, and then it should not be a problem if it's an aggressive gas. We choose the material accordingly. It can be hexalloy, it can be titanium, it can be plastic, as I said, or just stainless steel. And we check what is the right material for the application.
Mm-hmm. Okay. So there's another question. It is, can ultrasonic flow meters be used for either liquids or gases and even two-phase flow examples? What sort of repeatability or accuracy would you expect?
The ultrasonic sensors that we lately developed and brought to the market are purely for gases. Generally speaking, there are ultrasonic sensors, clamp-on versions, for example, that can be used for liquids as well. So it's both possible. I know from some of our competitors that are able to measure liquid and steam and gas with one type of sensors, but for the gas flow, then they require certain pressure in the air or in the gas. And as I said, for the lately developed product that we have here, it's for gases only, and it's basically for combustion engine test benches. And it will be developed further for the gas, for the chemical industry. The accuracy here is about 1%. And the repeatability will be even less, so it will be very, very precise measuring equipment.
Okay, thank you. Here's another one regarding the US and Canada. Do Höntzsch for the future also look into this market for specific qualifications? So especially in regards to SIL and ATEX certification.
Yes, what we have is CSA certification for some of our sensors. That's the Canadian standard. And as far as I'm aware, this is also then accepted in the United States. We have a partner in Canada, a sales partner, and by this or by him, we sell already into Canada, and we also sell directly to the final customers into the United States. So that's the situation at the moment. If there are more inquiries coming from the United States, then we may think of further certifications.
Okay. Here's another question. In the thermal oxidation process, which sensors are utilized in the different application steps?
We would use a thermal mass flow sensor for the gas, the natural gas coming to the flame. We would use a vortex sensor due to the seal requirement, if there's seal requirement for the air coming to the flame. And we would also use a vortex sensor for the incoming exhaust from the process, that is, for example, the paint booth. For the outgoing gas to the open air, we would also normally use a vortex sensor, because sometimes there will be remaining particles or small amount of moisture of condensation in the process, in the gas.
Okay, thank you. Yeah, this is pretty much it. So with this, if there's no further question from the audience, and I don't see anything coming in right now, I would like to thank Dr. Schmidt for this very interesting introduction. And oh, here's another one coming in. Maybe we can clarify this. What would the pipe or duct diameter limit be for ultrasonic flow sensors?
For ultrasonic sensors, as we have I've just talked about, for the combustion engine test booth, we are at the moment at 250 millimeters maximum diameter. Theoretically, it's possible to create larger ones. So when there is a demand for a larger one, it's a matter of designing and testing the equipment. But from the physical principle, it can go larger.
Okay, good. Well, then, thank you very much, everyone, for participating today. And yeah, I would like to close this session now. Thank you for your questions, for your interest, and see you soon in one of our next webinars.
Thank you very much from my side as well, and have a nice weekend.
Have a nice weekend. Goodbye, everyone.